Today, we still get more than 75% of the global energy supply from fossil fuels, while we only get 1% from wind and solar. Now, we all know that we need to stop using these fossil fuels because they create pollution and CO2 problems. But how? How are we going to do that? In my country, we have been building wind power for more than 40 years now, essentially all my life. And we're still only able to supply a fraction of the country's total energy supply from wind. Fossil fuels also create other problems with wars and conflicts around the world. And that results in migration and refugees and hardship for a lot of people who didn't get a lot of benefit from those fossil fuels in the first place. But I believe that it's the responsibility of our generation to find a solution to this transition from fossil fuels to something else. And it's not going to be the global energy companies that are going to help us do that. And I don't think the politicians are going to do that for us, at least not on their own. It's not going to be the guy on the street in Bangladesh or somewhere that's going to solve the problems. It's us. It's people in the rich part of the world. It's people like you and me and people in other rooms like this that are going to solve this problem. And I have a great confidence that we can find a way to solve it. And one of the reasons is I read an article on the internet 5 years ago where it said a ball this size, made out of thorium, can supply you with all the energy you need for your entire life. And there's enough thorium on this planet to power the entire humanity with energy, plenty of energy, for more than 1,000 years. And then it said in that article that thorium costs next to nothing. And I had to admit, when I read that, I didn't believe it for 1 second. So I just put it away and I went on with my life. But I'm the kind of guy who reads a lot of tech news. And these stories about molten-salt reactors and thorium energy kept on popping up in those tech news streams. And I read a few more of those and I was curious. And then I said to myself, hey, I'm an engineer. And engineers are supposed to go home and calculate if it's really true, all the things that we've been told in the media. So I did. And thorium is an element in the periodic table. It was easy to find all the numbers that I needed for my calculation on Wikipedia. And in less than 15 minutes, I was able to calculate and get the result. And it's true. I was stunned in a big way when I found out. It's really true. There's all the energy that I need for my entire life in this ball. Not just for electricity, but for everything. For heating my house and cooking my food, and for building roads and schools and houses and hospitals, and to manufacture all the products and goods that I need throughout my entire life. And transportation, everything, for 100 years in this ball. That fascinated me more than just a little bit. I thought, this is super cool. I want to get me one of those balls. So I went on the internet and I Googled, where can I buy one of these? But I couldn't. It turns out that thorium is slightly radioactive, so there are some rules and regulations. But more importantly, we're not using thorium anywhere in the industry today. That means there's no demand for thorium. That means there's no supply, and there's no market and no market price. But through that research, I did find out that it's true, that there's lots of thorium in this world for many thousand years. And when we mine for other materials that we need for high-tech products and electronics, we get lots of thorium out of the ground in those mining operations. But because there is no demand for it, the mining companies, they don't want to refine it, so they just put it back in the ground. But we have been using thorium a little bit in the past, and we know how to refine it, and it's actually an easy and very simple process, not very expensive. And that means that if we were to mine thorium at an industrial scale, then a ball this size would cost you less than $100. Ladies and gentlemen, that is less than $1 per year for your entire energy supply. Think about that next time you go to the gas station and fill up your car. Of course, I also thought about that, and it's like, this seems really great. So we have all this energy in this ball, but why are we not using it? What's the problem? What am I not being told? And then I found out, of course, it's because we need a machine to convert thorium into energy. And that machine is probably super duper difficult to make. It's probably something that the scientists have been spending billions of dollars and decades of research, and they have no idea how to make it work. But around that time, I'd also found out that there was a small group of scientists back in the 60s at Oak Ridge National Laboratory in Tennessee in the United States. And they had built a machine that they called a molten-salt reactor. They had a very limited budget, and it took them a few years to build the machine. And then when they turned it on, it worked right away. And they ran it for 5 years. Now, that machine wasn't able to convert thorium into energy, but the scientists knew that if they could make this machine work, then they could build the next version, and the next version was highly likely able to work, and it would convert thorium into energy. But then the government at the time, and the president, this was Nixon at that time, he had promised some people in California that he wanted to create jobs over there. That government, they didn't really understand this project of this new technology in Tennessee, so they decided to shut it down and spend some of those money in jobs in California. And then through some really unfortunate circumstances, this technology didn't get to the public's attention for almost 50 years, until a guy called Kirk Sorensen heard about it. Then he started to dig into this, and he found out about it, and he started to publish some of these papers that the scientists had written in the 60s on the internet. And then people started to realize, holy cow, this is like the holy grail of energy production. And we've been sitting on top of it for all this time. And then word started to spread around the world, and people got involved, and that's of course also how I got involved. Now these molten-salt reactors is really the key here. So I want to tell you a little bit more about them. First of all, it's a nuclear reactor. But it's very, very different from the old type of nuclear reactors that we have in old power plants today. I want to just quickly go through how they are different. Well, first of all, the old power plants, they're of course really big buildings, and they take many years to build, and they're very expensive. I think you all know that. And then they rely on electrical systems and humans in control rooms with lots of dials and buttons to make sure that they run safely. And then finally, when we put uranium into them and burn that uranium, those old type of reactors are only capable of burning a few percent of that fuel. So what we get out of the reactor we call spent nuclear fuel, and it's radioactive and needs to be stored safely for 100,000 years or more. And that has caused a lot of headache in those countries who rely on nuclear energy today. But let's try to compare that to molten-salt reactors. Those reactors can be built really small, and they can be built on an assembly line, just like we build cars and airplanes. And when we do that, we can get the price to come down and the quality to go up over time. And once we get into volume production, these molten-salt reactors can be built at a very, very different price point than old type of nuclear power. Very small price. And then, with regards to the safety, molten-salt reactors is known to be one of the safest reactor types that we know of. I want to point out two things. There's one safety theme called walk-away safety, and it simply means that if all the human operators were to walk away from a reactor that is running, and we lose the control systems or the electricity, then these reactor types are still capable of shutting themselves down and come to a stop for using simple physical and mechanical properties. And when they stop, they don't release any harmful materials to the surroundings. The other principle is called the Prime Minister safety. And it simply means that no matter how many stars you have on your shoulders, you will not be able to operate these reactors in a way where they become dangerous or unsafe. Even better, if somebody tries to fiddle with the reactor in ways that they shouldn't, then these reactors are capable of letting the world know about it before things get out of hand. But what really got me hooked is feature number 4, about the waste. Because these molten-salt reactors are capable of burning all the fuel that we put into them. That means if I put this ball of thorium into that reactor and burn it, what I get out is a ball the same size of waste, and a tiny fraction of that is radioactive. And it needs to be stored safely for 300 years. But we already know how to store something very safe for 300 years. So essentially, all the headaches have been cleared up. But what's really great is that we can take the spent nuclear fuel from these old type of reactors and bring it over here. And then we can mix it with the thorium. And then we can burn it one more time and get additional energy out of it. But also really importantly, when we burn it the second time in the molten-salt reactors, we reduce the number of years that the waste have to be stored, also to 300 years. When I heard about all of this, I decided, this is really great. Why are we not using it? And I decided I could not just sit around and wait for this to happen. I had to get involved. So I started to travel the world to go to conferences about thorium energy and molten-salt reactors and build an international network of scientists and engineers that I could work with. And then here in Copenhagen, I was also able to meet with some really great scientists and engineers, and we formed a group, and eventually we decided to start a company together. That company is called Copenhagen Atomics. And our dream or our vision in Copenhagen Atomics is we want to help bring this new energy source to market, bring this technology to market. And we want to do that through openness and through collaboration. We want to collaborate with people from other countries, scientists and engineers. And we have this long-term vision that we want to build these molten-salt reactors inside a 40-foot shipping container on an assembly line. and then we want to ship them out into the world to where the waste is and help burn that waste out of existence. So those molten-salt reactors should be configured as waste burners, and that's why we call it the Copenhagen Atomics waste burner. Now, let's step back and talk about, or rephrase what it is I've told you here. First of all, there's this new type of fuel that we didn't realize, most of us, that it existed. And there's lots of it, and we can use that to replace fossil fuels. And then there's this machine that allows us to burn it in a way where it produces no pollution, no CO2, and it can even help us reduce the stockpile of radioactive waste that we have around the world. But I don't think that's really great. But the biggest thing for me is the last point, is that by implementing this system for producing energy, we will be able to produce enough energy for all of us in this world. So we don't have to fight over energy anymore in wars and conflicts. And hopefully this will help us reduce the wars and conflicts and all the problems that are related to that. And I think it would be really great if our generation could achieve that, to implement a new energy system like that, that could achieve all these things instead of the fossil fuel. So I want to ask you to reconsider, how should we build a new energy system in this world? If you were responsible, how would you design such a system? I'm pretty sure that you probably not give special rights and unfair advantages to a few rich countries or a few global corporations, and then allow them to take advantage of the fact that we all need energy if we want to live a prosperous life. And you would probably not allow them to influence our political systems and many decisions that are made around the world. And then there's also these problems where decisions are made about our environment. For example, I'm thinking about tar sands and gas fracking. I mean, we've really become so hungry for fossil fuels that we're trying really hard to destroy the world around us. So I think it would be great if we could find ways to solve that by rethinking how we have the energy system. And finally, I want to take it to your home and think about, in your home you probably have running water and internet connection. Now, nobody owns the water in this world, and nobody owns the internet. But still, for a small monthly fee, usually a flat fee, you can get utility providers to provide those services to your home. And it's of great benefit to you. So what if nobody owned the thorium in this world? And nobody owned the technology to convert or to build these molten-salt reactors? Then maybe, someday in the future, we could have an energy system where, for a small flat fee per month, you would be able to get all the energy you want into your house. You can use that in your 3D printer to print all kinds of products you need, and of course to heat your home and cook your food, but also to charge your electrical vehicle, whether it's a car or it's some kind of flying device. I think that's the kind of future that we should try to aspire to. But of course, now I told you all the great things about thorium energy. So why don't we have it already? And of course, that's because there's still some things that needs to be solved. There's a stack of people problems that has to be solved. And then there's a smaller stack of technical problems. The really big problem is that they're really interconnected. And it's like the hen and the egg problem. You cannot solve one without having solved the other one first, and vice versa. So it makes it really difficult to get started. And nobody wants to be the first one to come in and invest. Everyone else can just come later and get a free lunch. So there's some hurdles that we need to attack. I think it's going to be people like you, people in the rich part of the world, who should bring this forward. And how can you help? Well, the least thing you can do is to tell your colleagues and friends and family that this new energy system exists, that it's possible. Because before, as a society, before we know about this, we cannot have a debate about it. And then we're definitely not moving anywhere. But then the next steps is that we need a lot of people with skills in communication and law and design and graphics and many of these soft skills to help us build this energy system. So I invite all of you who have an interest in building a better world for the future to come along and help with this task so that we can build a better future for you, and for me, and for the next generations. Thank you.